We're finally into section 1.2, which is word problems and applications. And we're talking about specifically word problems that have to do with linear equations. So hopefully all of ours will have a linear equation today. Math doesn't live in a vacuum. We're not just trying to solve math problems just to solve math problems. We are trying to apply them to the real world somehow. So a general rule of thumb for solving word problems is that there's no magic formula, but there are some strategies that will help. I say there's no magic formula, but there are a lot of formulas that will help, and we'll learn a couple of those along the way today. So our strategies that we're going to use are first to read the entire problem, try to understand what it's asking. That's very important for a problem, to read it and try and understand what it's actually asking you. Then if you can draw a picture of the problem, that helps oftentimes. If it's talking about geometry, about a triangle or a rectangle, draw out the triangle or draw out the rectangle. Finally, try to write the equation and then make sure your solution makes sense with the problem. Make sure that it equates to something real in the problem as well. We're starting off with one of the important formulas I was talking about. So this formula right here that I have circled, I equals PRT, is the formula for simple interest. Anytime you have a simple interest problem, you're going to use that formula right there. What those things stand for, I is interest, P is principal, that's the amount of money that you initially invested or borrow. I like to say P is the amount you put in, right? I is the interest in the end. R is the rate. The rate is a percentage most of the time. And T is the amount of time in years. So if it's not an exact year, you need to round it to the nearest year or make it in the format of years. So in this example, they give us 18 months, for example. That's not in exactly years, so we need to transfer that to years. 18 months is 1 year and 6 months. That's the same thing as 1.5 years. Anytime you have an interest rate that's a percent, we know that we have to convert a percent every time to a decimal. If you have a percent, you have to convert it to a decimal. So 4% is the same as 0.04. Anytime you have a percent, you're going to move that decimal place 2 to the left. So for example, 2.5%, you move it 1, 2 to the left, and you have 0.025. If you have 0.2%, you still move it 2 places to the left, and you'd end up with 0.002. 0.2% is the same as 0.002. Let's read the problem they have for us here. If $5,000 is invested at 4% simple interest for 18 months, which is the same as a year and a half, the amount of simple interest is I equals PRT. If we go and try and fill in I, P, R, and T, we want to know what I is, we know what P is, we know what R is, we know what T is, so we can fill in those values in the formula. And then all we have is a multiplication problem. You can just type that directly in your calculator to get the answer. I equals 300. Does that make sense with the problem? We invested $5,000. We got $300 out. That does make sense. Next, Imani invested a total of $8,000. Part of the money was invested 2 years in a stock. The rest of it was invested in a CD. So the stock was there for 2 years. The CD was there for 18 months. Remember, that's 1.5 years. The stock was invested at 6.5% interest, that's 0.065. The CD was invested at 0.8% interest, that's 0.008. We want to find that if the total interest was $804, what was the amount in each account? So this 804 is going to be our total interest. Since we have two different accounts, we could say the interest from our stock plus the interest in our CD adds up to our total interest, right? So PRT from the stock plus PRT from the CD equals I. I'm just going to take the numbers that are in the problem and submit. So 804 for I. The amount of principal is the tough part because we don't know how much was invested in each. That's what we're trying to figure out. For the stock, if we call our stock X dollars, right? If our stock principal is X and we invested a total of 8,000, then our principal here has to be 8,000 minus X. Think about it. If you invested $2,000 here, this must be 6,000, right? It's 8,000 minus that 2,000. If you invested 4,000 here, this must be 4,000 because it's 8,000 minus 4,000. If we have to have 8,000 total, whatever we invested here, this is 8,000 minus that value. Summing those numbers into the formula. We get 804 is our interest. You see I have my X here and my 8,000 minus X here, right? 0.065 is that 6.5% interest. 0.008 is the 0.8% interest. The first one was at 2 years. The second one was at a year and a half. Again, we just have a multiplication problem here and then simplification. We can multiply here, We can multiply and distribute here and get an equation that looks like this. Combine your like terms, that's all your x's, and you end up with an equation that looks like this. Subtract the 96 over, and you end up with this. Divide by 0.118, and you look like this. I've already worked out these problems because it would just take incredibly long for me to write them out step by step. So I'm just going to step you through each part of the problems here. I would, as always, recommend when you get to a problem, once you get to a point where you feel comfortable, pause the video, try and work through the problem, and then you can catch up back with me. LaDonna borrowed a total of $10,000. That's how much she borrowed, right? That's the total principal. Part of the money was borrowed from a lending institution that was 5.5% simple interest. That's 0.055. The rest of the money was borrowed from a friend who LaDonna paid 2.5% simple interest. That's 0.025. LaDonna paid the friend back in 0.75 year and the lending institution after 2 years. Find if the total amount she paid in interest was $735. We know that's our I. How much was borrowed from each source? Take a second and try and sub in these values. Again, if our principal from one was x, then our principal from the other had to be 10,000 minus x because that's the total amount that she borrowed. So here's my initial setup. It doesn't matter here. You see that I've got x here and 10,000 minus x here. It doesn't matter which one you go with, okay? It does not matter which one you start with. This left one could have been x and that one could have been 10,000 minus x, just like in the last problem. Again, you distribute on the left, distribute on the right. You end up with something that looks like this. Combine your like terms and subtract the 1,100 over and divide by 0.09125. You end up with 4,000 equals x. Make sure at the end of the problem that you've actually answered the question that was asked. So here it asks how much was borrowed from each source. Notice that my x in this case was right here, right? My x was here. That was with the 0.025 and with the 0.75 years. The 0.025 and the 0.075 were both with her friend. So the x, this is how much she borrowed from her friend. If she borrowed that much from her friend and she borrowed a total of 10,000, 10,000 minus 4,000 means she borrowed 6,000 from the lending institution. Those numbers do make sense with our problem because remember she was trying to borrow a total of $10,000. $6,000 and $4,000 add up to our total $10,000. Solving applications involving mixtures. All right, so this is another thing you may see, and you can just follow the strategy that I show you here. If you ever have mixtures with, it seems like chemical compounds and things like that, the way that you do it is you multiply the concentration rate, that's going to be the percentage, by the amount of solution. So for example, if we have 6% of a 200 Cl bleach, that would be 0.06 times 200 gives you 12 Cls. If we have 94% of 200, that's going to be 188. You're always going to multiply the concentration rate by the amount of solution. Let's see an actual example of this. Household bleach has 6% sodium hypochlorite. How much household bleach, so we know this is household bleach, 0.6, how much household bleach, if it says how much, that's your X. So how much of that 6% should be combined with 70 liters of a 1% solution? So that'd be 70 times that 0.01. To form a total solution, this is a total solution, is 2.5%, so 0.025. And our total solution, if it's 70 liters, and also however much we have of the 6%, right, that would be 70 plus X. That's got to be somewhere in there. We're always in these types of problems where we have a piece 1 and a piece 2. It's going to be the total equals piece 1 plus piece 2. So here we have our total, you see that, 0.025 times 70 plus x equals 6% times x plus 70 times 1%. Again, we can distribute on the right side, multiply on the left side. We end up with something that looks like this. You have to remember to distribute the 0.025 to both. Combining like terms, moving things to the left and right, we can move the 0.025x to the left, move the 0.07 to the right by subtracting each of them. You end up with this. Divide by 0.035, and we end up with 30. Does that answer make sense for our problem? I think it does. We started with 70 liters of water, so our answer should be somewhere near 70, right? I think 30 liters makes sense. Here's another of these. Try this one on your own. Pause the video and see how far you can get. It says how much 4% acid solution should be mixed with 200 milliliters of a 12% acid solution to make 9% acid solution. This is our total again, so we know it's 200 plus x. If how much is x, 200 is the other. To make a total of 9% would be 200 plus x. The setup again is part plus part equals whole. So this part here plus this part here equals the whole. Distributing and trying to simplify. Subtracting numbers to one side and variables to the other side. You can subtract the 24 to the right. And you can divide by negative 0.5. You get x equals 120. That does make sense with the problem because our answers are close to 200 milliliters, so our answer here is 120 milliliters. Another helpful formula is with uniform motion. The formula for that is distance equals rate times time. Your distance is always going to be in feet or meters or miles. Your rate is going to be feet per second, meters per second, miles per hour, things like that. And your time is going to typically be in hours or minutes, depending on what the problem is. Here, Hikari participated in a 41-mile biathlon that included running and bicycling. Again, we have part plus part equals whole, right? We have two parts that add up to the entire 41-mile biathlon. She spent an hour 45 minutes on the bike, 45 minutes running. If her average speed on the bike was 12 miles per hour faster than her speed running, so we don't know what her speed running was, maybe x, but we know that her biking speed was 12 more than that. So biking, she was going x plus 12. Her speed running was x, her speed biking was x plus 12. Find her average speed running and her average speed riding. So here we have distance equals rate plus time. We have a total distance, right? Is going to be equal to the distance running and the distance biking. So the total distance equals RT biking plus RT running. It does give us her times for each. So her time biking was 1 hour 45. Her time running was 45 minutes. Her speed biking we said was x plus 12. Her speed running we said was x. Subbing those in, we get an equation that looks like this. The same process as before. We can distribute, subtract numbers to one side, variables to the other side, and divide to get a final answer. We get x equals 8, and we sort of need to analyze this. We said that running is x, right? So this is her running speed. We want to know her average speed running and her average speed riding. We said biking was x plus 12, right? So that would be 8 plus 12 would be 20. Biking. All right, here's another. Jetty drove from Miami to Orlando, a total distance of 240 miles. We have a total distance. We're thinking probably, yep, he drove in two separate segments. 1 hour in traffic, 3 hours on the highway. There's our times for traffic and our times for the highway. His average speed on the highway was 20 miles per hour faster than his speed in the city. So we'd call his city speed x and his highway speed x plus 20. It was 20 faster on the highway. Determine his average speed. So his distance should be equal to his distance on the city and his distance on the highway. Sub it in the things that we know. Total distance 240. City driving we said was x. City traffic he spent 1 hour. Highway driving, his speed was x plus 20. Highway driving, he spent 3 hours. Same process, distribute, move variables, try and solve for your variable. And here we get 45 equals x. See that I noted that that was city driving. That's because we said X was city. This problem wants us to find the average driving in the city and his average driving on the highway. We have the city driving. To find the highway, we said highway driving is X plus 20, so 45 plus 20. That means 65 was his speed on the highway. All right, rate of work done. These are a little bit challenging. We've got a mail order company. Derek can process 100 orders in 4 hours. Michaela can process 100 orders in 3 hours. How long would it take them to process 100 orders if they work together? This is part plus part equals whole still, right? It's part plus part equals whole. Derek processed 100 orders per every 4 hours. 100 per. N is the same thing as per. 100 orders per 4 hours. That means that we could set that up as a fraction. If you see per, you could set it up as a fraction. 100 orders in 4 hours, we could set it up as a fraction. So Derek's speed plus Michaela's speed should be their speed total, right? Derek works at 100 units per 4 hours. Michaela works at 100 units per 3 hours. And we want them to get 100 units done, right? Working together, and we don't know the time. That's what we're trying to solve for here. We can solve this just like we do every single fraction equation. By getting rid of the denominator, we can multiply the top by every different denominator. So multiply by 4 and 3 and t, 4 and 3 and t, 4 and 3 and t, and then eliminating the things that match up. So here the 4's match up, here the 3's match up, and here the t's match up. Distribute the things that are left over. So 3t times 100, 4t times 100, and 4 times 3 times 100. Should give you an equation that looks like this. Combine like terms on the left, divide by 700, and you end up with t equals 12 over 7 hours, which is the same as 1.71 hours. That's our time to process 100 orders. If they want to process 1,400 orders, all that is 14 times as many. So all we have to do is say, take this number right here and multiply it by 14. That will give us our time for 1,400 orders, since it's 14 times as many orders. Here's another similar problem. Sheldon and Penny are awarded a contract to paint 16 offices. Once preparation is complete, Sheldon can paint one office every 30 minutes. So Sheldon can paint one office every 30 minutes. We can set it up like this, office per minute. Sheldon can do one office per 30 minutes. Penny can paint one office every 45 minutes. How long would it take them to paint one single office altogether? We don't know how much time yet, so we'll use a t there. Again, get rid of your fractions by multiplying by 30, 45, and t. 30, 45, and t, 30, 45, and t. Eliminate the things that match up. Multiply what's left, 45t plus 30t. I'm going to type in my handy dandy calculator 30 times 45. And I get 1,350. Combine like terms, you get 75t equals 1,350. Divide by the 75, and you get t equals 18. That's how long it took them to paint one office. And if we want to find out how long it takes them to paint all 16 offices, all we have to do is multiply that by 16. And we get 288. 288 minutes to paint all 16 offices. 18 minutes to paint one, 288 to paint all 16. All right, finally we have solving involving proportions. Proportions are going to work a little bit differently, but it's just fine. If you ever have a proportion, one thing you can do is the same thing that we have been doing, just eliminate all your fractions. So if I had a over b equals c over d, I can eliminate by multiplying by b and d, b and d. Remember, We're just trying to get rid of all the things that match up. You're going to set it up in a similar way that I have been doing these past ones, where you have, as long as you have the same thing consistently on top and bottom, offices on top, minutes on bottom, you're going to end up with the right answer. In a jury pool, there are 8 more men than women. If the ratio of men to women is 8 to 7, determine the number of men and women in the pool. So we can set this up as either men over women or women over men. It does not matter which one you choose to be on the top and bottom. The way I chose to set it up was men over women. So 8 more men. It's an 8 to 7 ratio, right? It's an 8 to 7 ratio. There are 8 more men than women. So if women is X, then men is 8 plus X. There are 8 more men, right? So I keep my men on top. Men is 8 to 7. Men is 8 plus X. Women is X. To clear these fractions, I can multiply by 7 and X on top. Eliminate the things that match up, right? So we can eliminate the 7, eliminate the 7, eliminate the X, eliminate the X. Multiply what's left over. And when you distribute, you end up with 8x equals 7x plus 56. Subtract the 7x over, you get x equals 56. Remember we said that x is women up here. If we want to know how many men, we know men is 8 plus x. So our men should be 64. 56 plus 8 makes 64. One more of these. In a community college environmental club, there are 4 more freshmen than sophomores. So if there are X sophomores, that means there's X plus 4 freshmen. See that? 4 more freshmen than sophomores. This results in a ratio of 13 freshmen to 12 sophomores. So I can do freshmen over sophomores, or I can do sophomores over freshmen. It does not matter which you choose. The way I chose to do it was freshmen over sophomores. We know the freshman to sophomore ratio is 13 to 12. So freshmen on top, sophomores on bottom. We'll keep freshmen on top, we set as X plus 4. Sophomores on bottom, we set as X. Again, we can multiply by whatever we have on the bottom, 12 and X, 12 and X. Eliminate the things that match up. So on the left, we can eliminate the 12s. On the right, we can eliminate the X's. Distribute what's left, 13x equals 12 times x plus 4, which is 12x plus 48. Subtract the 12x over, we get x equals 48. Remember up here we said x is sophomores. If we want to know how many freshmen, freshman is just x plus 4. So 48 plus 4 gives you 52 freshmen. All right, word problems are not going away. We're just going to learn new things like quadratics and things like that, and then we're going to try and find ways to apply that. What we did today is certainly not every different type of application. It's not every different type of word problem. You'll see other different types involving shapes and things like that. As always, if you could draw a shape, if you can draw the word problem out, it always helps, right? And always go back to make sure that you've actually answered the question the way that it was asked.